Hello everyone, in this video let's discuss about the series voltage regulator. If you are new to our channel, please subscribe for more engineering related topics. To design the series voltage regulator, we will use the transistor. So this Q means transistor. So this transistor will act as the controller of this circuit. This will act as the controller of the series voltage regulator circuit. Now at the input side, that is V in voltage, we are giving the unregulated DC voltage as the input voltage to the series voltage regulator. Now at the output side, we will be getting an output which will be equal to the Vz. What is Vz? The voltage across the zener diode minus VBE. What is VBE? Voltage across base emitter junction. Because it is around the voltage out, because our voltage output is here, no, so it will be between Vz, that is zener voltage, minus the voltage across the base emitter junction VBE. So V out is equal to Vz minus VBE. Now let's discuss about some properties and advantages and disadvantages of series voltage regulator. This series voltage regulator will only operate in active region. In active region. What is active region? In where the current will change as the voltage will be increased. So because we are using the transistor to design the series voltage regulator, transistor does its operation only in the active region. As the transistor will do their actions or the operations only in the active region, series voltage regulator will also be operating in the active region itself. Next, since the Q, that is transistor, and the load resistance RL are connected in series, both are connected in series, there will be maximum power dissipation taking place. Maximum power dissipation because of the series connection of transistor Q and load resistance RL. So it will be considered as some of the disadvantages. Now the major disadvantages are, first one is no protection to short circuit. No protection to short circuit. If there will be a short circuit because of the overflow of the current, there is no protection for it. And another is, as the temperature increases, output voltage may vary. That is, as temperature varies, output voltage also varies. So we can tell that it will be dependent on the external environment, that is external temperature, which will be applied also. Now series voltage regulator will work in two conditions. That is, first one will be if the output voltage increases. If output voltage increases. Second one is if output voltage decreases. So how we can know that the output voltage increase or decrease means by knowing the value of VBE, because we know the formula of the output voltage, V out is equal to Vz minus VBE. So we also know that the zener voltage will be a constant value. Therefore we can say that V out is equal to minus VBE, or V out will be inversely proportional to VBE, because minus, no, so VBE will be inversely proportional to, V out will be inversely proportional to VBE. So as the VBE value decreases, V out value will increase. So this condition. If the VBE value increase, then V out value will decrease. So this is the second condition. Now see the circuit. So we said that output voltage increases means the VBE value will decrease. So we said that if voltage V output will increase means VBE value will decrease. So VBE value will decrease in the condition if output voltage increases. As VBE is in this terminal, no, that is between base and emitter. As VBE value will decrease, therefore the current near it, that is IB value will also decrease. Next, we also know that this transistor Q is a current controlled device. That is, if output decreases, input current also decrease. If input current decrease, output current also decrease. Therefore, if IB decrease, the input current IC will also decrease. So IC value will also be decrease. As IC value decrease, the voltage across the collector and the base terminal, what it will be called as VCB or VBC, this value will increase. As the input current IC value will decrease, the input voltage VCB value will be increasing. So this will be called as the input part and this will be called as the output part, because we are giving the input voltage right here and output voltage is here. So input part and output part. As the input current IC will decrease, the voltage across this junction VCB. Second condition, that is output voltage decreases means then VBE value will increase. So as VBE value increases, current IB value will also increase. As the output current increases, input current will also increase. As input current increases, VCB, that is input voltage, will decrease. So write these conditions so that the series voltage regulator conditions will be satisfied. So hope you understood the concept of series voltage regulator. If you have any doubt, please comment below. If you like the video, don't forget to subscribe. Thank you.